Hello, my name is Rebecca Abraham, and I would like to present our senior design project on behalf of my team. My teammates are Spencer Don, Luke Later, and Caleb Parrish, and our project is titled Statistical Analysis of Solar Power Generation Tool. To start out with a business background on our project, Clarence Technologies, who is the sponsor of our project, is in charge of the road-ready system that tracks a large fleet of trucks all over North America. To track these trucks, they have a device called the Master Control Unit, also known as MCU, attached to these trucks, which collects various data like GPS location, customer details, device ID details, and various other details and sends it back to the company. These units are self-powered by a solar panel and are, on average, running very efficiently. However, this is where the needs of our project comes into play. Since these devices are powered by solar energy, there is a wide range of sunlight issues that is possible based on the location where the trucks are stationed. Since the system relies on the individual MCUs to work and be able to send data to the company so that they can keep track of it. And this is where the question arises on why does the shortage happen for certain trucks and not for others. Original hypothesis that was provided to us by the company is that this was caused due to weather and season changes, which causes the units to not be able to charge fast or cause the device battery to lose power due to the weather based on lack of sunlight. And to understand this, we developed our objectives. One of the main objectives for our project was to create a system that takes in all the data collected from the trucks and generate heat maps of chosen areas based on the power level of that trucks. These heat maps will be compared to weather trends in that area and see if there is any correlation between cloud coverage and weather to the lack of power in the units. Further, we also provide other data analysis tools, such as charts that can help to view the data in a statistical manner. And finally, it also has certain parameters or filter options that the user can filter the data and generate the heat map based on that. And now to just give a brief demo of our project. So when the user first runs the system or the application, it brings them to a page that looks like this, where they can upload as many data files as they want. So if I was to upload here, I can upload a data file, which gets passed to generate heat maps. Once the data gets passed, it generates heat maps. And as you can see, there are two populations here, population A and population B. The left one is population A and the right one is population B. From the description also, we can notice how these graphs are charted, how these maps are charted. The one on the right maps generates a heat map of max battery percentage of 30 and below, and it is for the location of EDPA. However, we can see there is no data available. So when there is no data available, there is no heat map generated. But when you look on the right, we can see a heat map generated for Pittsburgh, PA, where it shows a max battery percentage of 50 and below. And further, as we scroll down, we can see charts which can give various information like median battery percentage, mean battery percentage, standard deviation of the battery percentage, and different weather information, starting with the temperature, and it depends on the locations that are provided. So on the left, we can see for EDPA, on the right, we can see for Pittsburgh, PA. Then we can see cloud coverage, the solar energy, and solar radiation, and lastly, UV index. And if you can notice, since there is no mean, median, or standard deviation data on the left, this is because there is no data for the battery percentage on which the heat map is generated, which is 30 and below. And if you would, however, if you were to change the these user inputs, which filters the maps and plots the maps differently. Let me say in this case, I put a data of 80, and let's say I put a different location, let's say Houston, Texas, and then generate population A map. This generates a new map which shows the points in Houston, Texas. And from the description, you can see it is showing a maximum battery percentage of 80 for the location Houston, Texas. Further, the maps can be filtered based on customer ID and device ID. And if I was to put a customer ID of any value, let's say, if you want to, the user can also enter, and then it brings in the values depending on what we enter. So let's say 155, and I generate population B. It generates a new map of only 3 data. Further, if we want to create the heat map based on the device ID, if I was to put the device ID 8474633381, this gives a different map for some of the data points plotted for that device ID. Further, this heat maps can be filtered based on the date range, what the user wants to select, and depending on the files that are uploaded into the system. And that is our system in whole. Thank you for watching.